So hello everyone, good afternoon. How are you all? So guys, we are starting with our physics part here, and the topic that we are going to discuss today would be unit and measurements. So guys, what kind of questions are framed here? How these questions are actually asked? We'll be discussing all those things. But in the very starting, this topic is extremely important because all the basics that will be linked in the future part of this chapter, I mean the future topics, they all are actually linked here only. So what kind of questions are framed from this part? How we are going to link it with the other topics? Let's have a discussion. So first of all, talking about the topic, so what is it? So we are talking about the units and measurements, right? So first of all, what is measurement? Let's have a discussion here. So in this class, we'll be having some of the numericals as well, because there are questions from the significant figures which are asked in the examination. Apart from that, there are some things from the topics as well. So first of all, discussion about measurement is important. So let's have a look. Now, physical quantity, guys. Do you know what is physical quantity? So all those quantities that can be measured or defined, they are known as physical quantities. But this is bookish language. It looks quite typical to understand, right? So the basic idea will be, let's have a look at this water bottle. Now if I'll ask you, what is the volume of this water bottle? So can you please answer? So you'll say, sir, obviously it's a simple question because we also have our water bottles. So we can say this is of 1 liter. So guys, when you are answering me, it's of 1 liter. How you were able to answer? Because you were comparing this quantity with the known quantity. This is unknown quantity, right? We don't know about it. But since we have our water bottles at our home, so from this water bottle that is that is present at our home, we can actually try to compare it, right? So this means we are comparing an unknown quantity with the known one that is present at your home. This is what measurement is. Now, again, I'll repeat my same question. What is the volume of this water bottle? So someone might say it's 1 liters. One of the candidate might say, so it's of 1 liter. Another candidate might give this answer in milliliter. Someone might say, so it's of 1000 ml. Now tell me one thing. The first candidate is correct or second one is correct? So obviously both of them are correct. So that means, so the units which you are telling us, they are of different system, there are different systems here. So for measuring the units, we have several systems. So in order to proceed towards the system, we need to know these basics here. The numeric value that is mentioned, the numeric value that is mentioned here, that's known as magnitude. What is it? This is known as magnitude. And also the units that are mentioned here, both the things are of extreme importance if you want to measure something. So it's not only about the volume, it might be about the length. Let's say we are talking about 20 meters. So here also see the numeric value, that is magnitude, and this is the unit. So measurement is the comparison of unknown quantity with a standard, and yes, there are two parameters. One is magnitude, another one is unit. So let's say take an example, 20 newtons of force, where force is a physical quantity and 20 is the magnitude. Also Newton is the Newton is the unit. Now guys, in this chapter we have already started it, but what we are going to discuss, we'll discuss some of the numericals. We are also going to discuss the dimensional analysis, because in most of the cases we are aware of the units. That's the basic concept, right? But when the questions are asked from the dimension formula, most of us think that it's quite typical topic. Let's leave it. But there is no need to leave it. We'll discuss this in next 15 or 20 minutes. First of all, let's start with this units part. So talking about the systems of unit, so it may be the CGS unit, it may be FPS, it may be MKS. So CGS system stands for centimeter, gram, second. See, centimeter, gram, second. Similarly, for the FPS system, we have foot, pound, second. For MKS, we have meter, kilogram, second. And that here, now I want to know one thing. So you've discussed about CGS, FPS, MKS, but there is an internationally accepted system that is known as SI system. So is it any separate system? No. SI system is actually linked with this MKS only. So SI, that is international system, is globally accepted standard, and that uses the powers of 10 with prefixes for easy conversion. Let's say I'm talking about kilo, for example. So it can be expressed as 10 to the power 3. So it's easy to understand this, and yep, we can easily express these units. So it's not only about the positive powers, it's also about the negative powers. So these are the positive and negative prefixes. But I'll before moving forward, I just wanna ask you one of the important question. Guys, please tell me, what is the SI unit of time? What is the SI unit of time? So I'm giving you four options. The first one is hour, second one is minute, third one is second, and the fourth one is all of the above. Guys, what do you think? So here I want this answer. So Aviral is going with seconds, Adi, Rohit, Blessy, everyone is going with second, but Nan is going with D, right? So guys, all the candidates who are going with second, they all are correct, but I need to explain this. All would won't be the answer. SI units are actually fixed, and we have just a single SI unit. We'll be discussing about those fundamental quantities in next 5 or 10 minutes. So yes, here the correct answer is going to be second only. Similarly, I won't write it. I directly ask, guys, what is the SI unit of temperature? Answer please. So I'm giving you options: Kelvin, degree centigrade, degree Fahrenheit, or all of the above. It will give you the clarity that SI unit is always single. So thank you everyone for answering. So in the same way, for the temperature, the answer will be Kelvin. It won't be degree centigrade, it won't be degree Fahrenheit. So absolutely correct. So yes, that's great, guys. So yes, I'll be moving towards that quotation in the next 5 minutes. But as of now, these prefixes are important to understand. So for the quota, we have 10 to the power 30. 10 to the power 27 means Rona. 10 to the power 24 iota. 10 to the power 21 zeta. 10 to the power 18 exa, 10 to the power 15 peta, 10 to the power 12 tera, 10 to the power 9 giga, 10 to the power 6, this was asked in the examination previously, that is mega, 10 to the power 3 kilo, 10 to the power 2 hecto, and 10 to the power 1 deca. So this was the positive one. What about negative ones? So we'll start from 10 to the power 1 only. It's deci when it's 10 to the power minus 1, centi for 10 to the power minus 2, milli for 10 to the minus 3, micro for 10 to the minus 6, nano for 10 to the minus 9, pico for 10 to the minus 12, femto for 10 to the minus 12, sorry, minus 15, atto for 10 to the minus 18, zepto 10 to the minus 21, yocto minus 24, ronto 10 to the minus 27, and quecto 10 to the minus 30. So these are actually the most repetitive ones. It's not only about the CGL. I have taken the example of all the SSC exams. So these questions were asked in CHSL, CGL, also GD, CPO. So the most repetitive ones are in front of you. Okay. So again, coming back to the same topic, that is physical quantities. What were they? Those quantities which can be measured, right? Or we can define it. So those quantities which cannot be derived from other quantities, they are fundamental. So there are total 7 fundamental quantities in SI, and yes, there are 2 supplementary quantities. So like length, mass, time, current, temperature, amount of substance, luminous intensity, they are fundamental quantities. But it looks quite typical, right? I'll make it quite easy for you. Guys, what is the SI unit of length? I guess you all are aware of. Please answer. The SI unit of length is meter, correct? But if I ask you about the area, what is the SI unit of area? So its unit will be meter square. Now see, meter is not derived from anywhere, right? But meter square, it can be written as meter into meter, which means we are actually deriving this quantity from the fundamental quantity. Understood? So yes, similarly, talking about velocity, it's what? That's meter per second. So meter from length per second, it is second inverse from time, which you all have already answered. So that means the quantities which are derived from the fundamental quantities are derived quantities, and units are obviously derived units. So here, what are those 7 fundamental quantities and those supplementary quantities? Let's have a look. So these are the 7 fundamental quantities: length, whose unit is meter; mass, which has a unit kilogram; time, which has a unit second; electric current, that has a unit as ampere; temperature, Kelvin; amount of substance, mole; luminous intensity, candela. These were the basic things which every one of you were aware of. Guys, I need to discuss dimension also because this is asked in the examination and I know most of the students will be confused here. So now I'm going to slow down my pace, I mean my speed, so that we can easily understand this. Now, guys, dimensions, for example, let me talk about length first. While writing the spelling of length, if I'll go with the initial, this L is denoting the dimension of it. Similarly, if I'll discuss about the mass, again, M is there in the starting. So M is the dimension of mass. And similarly for the time, we have dimension T here. And in most of the cases, this is the only sufficient part for a syllabus. Okay. Now, how do we calculate this dimension? Now that's the question. So taking here the basic example, again, I'll come back with the same topic in next 5 minutes. But as of now, I want to know the dimension of area. So in order to understand the dimension, can you please tell me what is the unit of same? Because this is the easiest one and you all can answer. So Kotesh, Adi, Rohit, please tell me what is the unit of area? Is it meter? Is it meter square? Is it meter cube? What is it? So it's very obvious, sir. No need to ask. We can easily tell. The unit of area is meter square. What is it? Meter square. So I'll write for you. The unit of the area will be meter square. But I'm not asking about the unit now. I want to know about the dimension. So see, meter means we are talking about length, right? So yes, and for the length we are dimension L. So its dimension will become L2 or we can say L square. So either you can write M0 L2 T0 or you can just write L2. I'll ask some questions here. Adi, here you will be wrong. I'll tell you why. So here see, uh, Gauze, Rohit, Kote, Nani and Aviral, you all were correct. No, 1 second. Guys, it's not m square. 1 second, 1 second, 1 second. Then it means I need to take a blank page. 1 second, guys. Huh? I'm taking a blank page for you because most of you were wrong here. Are you able to see the white slide, guys? I guess yes, right? No worries, no worries. Let me tell you again. So what happens? See, for the length, we'll go with L only. And why you were confused? Let me tell you. I asked you about area, right? And the unit of area was meter square. So the confusion where you all were there, it was like you were linking this m with mass. And I told you for the mass we have m. But this was meter. That's not mass, right? So guys, linking it with the mass would be wrong. Yes, you had to link this meter with length because it's this m means meter. So that's why we can either write it as, we cannot write it as m2. No, it will be written as L2 or you can write it as m0 because anything with the power 0 will be 1 only. So it will be m0 L2 T0. So in the examination you will either get this option or this as an option. Please confirm. Is this part clear now, guys? Mr. Aviral, Kotesh, everyone. Great. Okay, so I'll take another 5 minutes because I have few more things to discuss. Then I'll proceed here. So as we were discussing about this length, so yes, the unit of the length is meter, no doubt about it. That's meter. But do you know what is meter? How we are actually using this meter as a unit? So we have to refer with some of the unit so that we can easily tell that this length is of 1 meter. So in order to understand it in the better way, do you know what is the speed of light in vacuum? So the speed of light in vacuum is 3 into 10 to the power 8 meter per second. Very simple part. Now tell me one thing. In 1 second, what will be the total length that light will travel? So sir, what a simple question. You have already given its speed. So that means in single second, light can travel 3 into 10 to the power 8 meters, right? No doubt about it, right? Now guys, if I want to know how much time light will take to travel 1 meter, so it's very obvious it will be 1 upon 3 into 10 to the power 8 part of a second. This much time is needed for a light to travel 1 meter. Is it correct? It's simple as it, right? So this means, sir, 1 meter length is actually taken from here only. So what is 1 meter? So it is the length of the path of the light traveled in the vacuum in 1 upon 3 into 10 to the power 8 second. Now you must be wondering, sir, what 1 second? Sir, you are saying 1 upon 3 into 10 to the 8 meter per second, but in your slide it's mentioned 1 upon 299,792,458 of a second. Why this difference is there? Because this is actually the approximate value. We as a human being, we cannot remember all these jumbled figures easily. So in order to make it easy, what scientists have done, they have actually given the approximate value that we have mugged up right from our childhood. So the exact speed of light in vacuum is 299,792,458 meter per second. But yes, in order to make our calculation easy and also for our easy rectification part, this value was used. So do not worry, it is one and the same thing. Obviously, this is the exact value, that is 299 and so on, and 3 into 20 it is the approx value. I guess now you have understood what is the meaning of 1 meter, and that's clear, right? Okay. Now, guys, we were discussing about dimension. So the dimension of the length was L. Symbol for the meter is obviously M, and the CGS unit is centimeter. What is CGS? Centimeter, gram, second. Okay. So let's say after selection in the CGL, I had promised you that we'll have party after the selection, and let's say I had a good budget at that time when a selection was done. So after the selection, I told that we are going via Cordilla cruise. I guess most of you must be knowing about it. If you're not aware of it, please be aware of it because it's the best part. You must travel once. So let's say that was my promise. So I called you up. Please be at Mumbai. Now we are going from Mumbai to Goa via this cruise. Now, when we'll be traveling from Mumbai to Goa, obviously we are traveling via sea. Now within the sea, we won't be using kilometers as a distance. What will we'll use nautical miles here. So in order to measure the distance in the sea or ocean, so we use nautical miles, and that one nautical mile is equal to 1852 meters. Similarly, if distance is much more, actually it's very high distance, so the largest unit of distance is parsec. The largest unit of distance is parsec, which is equal to 3.26 light years. And do you know what is the full form? The full form of parsec is paralactic second. What is that? Paralactic second. And all these questions are asked in your examination previously. Full form, the largest unit, and so on. 1 light year is equal to what? So light year is the distance that light travels in 1 year, and it is equal to 9.46 into 10 to the 15 meters. An astronomical unit, so that's represented by AU. So it's the mean distance between the sun and earth, and its value is 1.496 into 10 to the power 11 meter. So yes, you need to remember all these things. Then kilogram, we are comparing it with a mass which is kept at Paris. So that's a platinum iridium cylinder whose mass is of 1 kilogram, and the all those you might have seen bars which are of 1 kilogram, they are actually taken, they have actually taken the reference from this structure only. Second, that's calculated from this atomic clock. Kelvin is the SI unit of temperature, and candela, that's the SI unit of luminous intensity. Okay, coulomb, so that's the unit of charge. So charge required to obtain 9 into 10 to the 9 Newton force between two equal charges at 1 meter vacuum, that's equal to 1 coulomb. Then what is mole? So that's the amount of substance as many particles as in 0.012 carbon 12 atom. But it looks quite typical, right? Let me make it easy. Guys, tell me one thing. Kotesh, let's say I have a sack that is filled with rice, and let's say this sack is of 50 kilogram. Fine. Now uh, I went to shop and I asked that I need 2 lakh sugar crystals. Will it be possible for that particular person to count it? Yes or no? So that would be impossible, and obviously he might say, I won't sell you anything, and if I'll find you, I'll just thrash you badly. So guys, that's impossible for a shopkeeper to sell you 2 lakh units of sugar, right? Obviously he cannot. So what we'll do, instead of uh, getting sugar in by counting the sugar crystals, what we can do, we can actually use another unit, another way of taking it. So what we can do, we can ask him to give 50 kilogram sack, or you can ask 5 kilogram of the sugar, or you can even ask 1 kilogram of the sugar. That is possible for him to weigh and give it to you, right? Similarly, talking about the oil, in most of the cases, normally oil, since it is liquid, it must come in liters, right? But in the northern India part especially, or in most of the part of India, you'll get oil in the terms of kilogram only. So 5 kilogram oil must, I'm talking about the mustard oil, or 1 kilogram of the mustard oil, or 20 kilogram of the mustard oil. So that's weighed and given to you, right? So we'll go with the units that's possible for us, right? So similarly, now if I want to take 12 bananas, is there any easiest way that I can ask for? How can I ask any seller if I don't want to use 12 banana? What I'll use? I'll use the term that is 1 dozen. What I'll use? I'll use the term that I want 1 dozen or 2 dozen or 5 dozens of banana. So he'll understand he's talking about 12 pieces. Simple. Similarly, if I talk about pairs, obviously 2 will be there. But again, same concept. Since I was talking about 2 lakh cubic crystals of the sugar, that was impossible to count. So I had another way, 50 kilograms and all. So guys, in the similar manner, if there are particles whose quantity is 6.022 into 10 to the power 23. Now, it might feel quite typical, right? So in order to express your views or express something that I want this or this was this much. Let's say we are talking about any gas, or we are talking about any volume of any liquid. So in spite of using this particular value, so what I can do? So these many particles are equal to 1 Na. And what is that? That Na is actually Avogadro number, which is equal to 1 mole. So the same thing is mentioned here. So amount of substance is equal to as many particles as in 0.012 kilogram of carbon 12. Here that number is equal to Avogadro number, which has this value 6.022 into 10 to the power 23. So I guess this part is also clear. Okay. So now guys, what are derived quantities? So the quantities which are derived from the fundamental quantities. So fundamental quantities, there were 7. Apart from that, there were 2 supplementary quantities, solid angle, plane angle, where its units were radian and steradian. But for the derived quantities, let's talk about acceleration. For the acceleration, we have unit that is meter per second square, right? So guys, here meter, length, second into second, again time. So it's derived, so that's a derived quantity. But how we are calculating these dimensions, now I want your support here, because the thing is, if you will practice here, it will be easy for you. Otherwise it will be typical in the examination. So it's a humble request that you all must answer whatsoever I am asking. So first of all, I'll start with the basic one, and then I'll take total 4 examples, and after the fourth one you will never have any confusion. So it's a humble request. Let's start discussion here. So first of all, what is dimension analysis? How we calculate it? So the process of establishing relationships between the physical quantities by identifying their relation with the fundamental quantities. So it was L, M, T, A, K. These are the dimensions we have discussed. So what is rule number one? Every term in an equation must have same dimension. Quantities of different dimensions cannot be added or subtracted. Second, dimension of any quantity on both the sides of an equation must be equal. And here the example is given. In order to calculate the volume of the sphere, we need to know the formula, that is 4 by 3 pi r cube. But 4 by 3 is constant, no dimension. Pi 22 by 7 or 3.14, again no dimension. It's only about r cube. What is r? Radius. Radius? Length. Length. That means L cube. So it is either L cube or M0 L cube T0. Did not understand? No worry. Now I'll make you understand with 4 examples as discussed. So let me take few blank pages, and everyone is requested to please answer here. I've taken 3 pages. So we'll start with the basic one. We have discussed about area, right? So now it's the time to understand from acceleration. Guys, I need to calculate the dimension of the acceleration. So please start answering. First of all, let's start with the unit of the acceleration. What is it? It's meter per second square, right? And in order to calculate the direct dimension, we know we are going to use m to the power x, l to the power x, and t to the power x. So first of all, m, what is it? That's length. So l, power is 1, so for 1 you need not write anything, but it's second to the power minus 2 because it's there in the denominator part. So it will be t, but it was in the denominator part, so it will be minus 2. And since there is nothing about mass, since mass is not there, so it will be m0. So in the examination, either you will be getting in the option as m0 lt minus 2, or you might get it as lt minus 2. So let me check how many of you answered this. Nani, Aviral, L2 t minus 1, Aviral, yeah, that's correct. So lt minus 2, lt, yeah, you all were correct. So this was the basic one. Let's make no, before making it complex. So Kotesh and all, I want this answer from everyone, Adi. So I'll take one more simple example, then I'll proceed with the quite typical one. Okay. So we have discussed about acceleration. Now my question will be, tell me what will be the dimension of what can be simplest one? Acceleration we have discussed. Let's talk about. Acha, chalo, I'll ask the very basic one. So let's go with momentum. So guys, how many of you can help me out? Because these are the previous year related questions. What will be the dimension of momentum? So for momentum, we need to know this. We'll discuss in the force and laws of motion in the next to next class. But as of now, what is momentum? Amount of motion contained in a body. So that's the product of mass and velocity, which means the unit will be kg meter per second. So everything is in front of you, and I guess now you can answer. So kg means mass, but power is obviously 1, no need to write. Meter, that means length. Second, but it's in denominator, so that's the unit of sorry, that's the dimension of momentum. What is it? Arey, that's great. So it's Gauze, am I taking your name correct? Is it your correct name? Gauze, I can, is pronunciation correct? Aviral, Blessy, Nani, and Veshu. So you all are correct. MLT minus 1. Fine. Now let's make it quite complex. Let's go with force now. Tell me, what is the dimension of force? Kotesh, correct. Dimension of the force. Now, with the force, my answer won't come directly from the Newton. Obviously, Newton is the unit of force, but it would be quite typical to directly answer it from here. So, Aviral, what I can do in this case, formulas are the easiest thing by which you can calculate the dimension. And from the Newton's second law, there's a formula that is derived as F is equal to m into a, where m is the mass and a is the acceleration. That is, m stands for mass, that is kilogram, and acceleration meter per second square, right? So guys, it's kg meter per second square, where kg is the mass, so m that is meter, that is length, and it's -2. So let me check how many of you have given the correct answer. So Kodesh with MLT -2, that's correct. Veshu, Gauze, Blessy, Adi, Aviral, and Nani. You all were correct, guys. Perfect. So it's the time to go with the final question. And this time I want to know the dimension of work. Please help me out, guys. I'll be very happy if you all will be able to answer this correctly. And I guess you all can answer it easily. Everyone, please try. Please give a try. Stuck somewhere? Okay, I'll help you out. No worries. So, guys, for the work, directly answer from Joule won't come, right? Directly answer from Joule won't come. But we are aware of work is equal to force into displacement. That means, so it was kg meter per second square, but you need to multiply with the distance or displacement, that is meter again. So it will be kg meter square per second square, which means kg, that means mass, meter, that is length, and second, that is time. So ml2 t minus 2. Let me check how many of you have given this answer. So yeah, I have those answers. So first Pawan is the first one to answer it, that is ml2 t minus 2. Then Gauze, Aviral, Adi, and Veshu. Salute, guys. Very happy, seriously. So yes, these questions are asked in the examination. Most of us gets confused, but now you won't be confused. So I'm proceeding further. I have one more subtopic to explain, and then we'll practice some of the questions. So we'll do this in the in all the classes. Now let's discuss about the significant figures, guys. What are they? So significant figures are those particular uh, it's a way to exactly express the number. So let's say we are talking about two significant figures, so I'll go with two significant numbers. So what is that significant number? So all the non-zero numbers are actually significant. Zeros between two non-zero digits are significant. If they are leading zeros, that is, if zeros are there in the starting, they won't be the significant numbers. But if zeros are added later on, they all will be significant. So yes, I'll be discussing the questions now, and we'll discuss about significant figures. But before that, whatsoever we have discussed today, let's have a discussion here. Which of the following pairs of the physical quantities have same dimension? Please try to answer. Guys, quantities which will have same unit will obviously have same dimension. Work has the unit as joule, but power, watt or joule per second, so no. Momentum, mass into velocity, that is joule, again no. Newton, watt, again no. But yes, both are going to have same unit, so obviously they will have same dimension. So all of you who are going with option number D, like quotation power, you all are correct. Next, so that's the dimension. Mass, energy, and work, they will have both same dimension. You have already calculated this. ml to t minus 2. Which of the following is the SI unit of luminous intensity? Lambert, joule, candela, or ampere? Which of the following is the SI unit of luminous intensity? Is it Lambert? Is it Joule? Is it candela or is it ampere? Guys, answer. No one? Areva, everyone. So yes, you all are correct. Candela is the correct answer this time. Next, 1 horsepower is equal to how many watts? So that's 746. So 1 horsepower is equal to 746 watts, and that's the unit of power. That's correct. What is the SI unit of magnetic induction? Is it poise? Is it diopter? Is it candela? So no, that's Tesla. So what is the answer? Tesla will be the answer. So Pavan, Adi, great. Absolutely correct. Next, which instrument is used to measure the radius of the wires? So see, if we are talking about the radius of the wires, that's done by screw gauge. And when we used to talk about the dimension of the bob, right? So like the radius and the diameter, that was done by vernier calipers. So here the answer will be screw gauge. Next, light is related to what? Energy, distance, speed, or time? The light energy. So sorry. Light year is related to what? So light year, obviously, so that's the unit of distance. So here option number B will be the answer. So how much light travels in a year, right? Okay. So light year is equal to unit of distance, not time, and it is the distance that light travels in a year in vacuum. Ratio is, if you have uh, understood this chapter easily, you can easily find. So 1 angstrom equals to what? Angstrom and nanometer. So it will be 10 to the minus 10 and it's 10 to the minus 9. Now guys, I have already written it for you. Please answer. Areva. So Sumeta is with B and Pavan is with A. Goz is also going with A. So see, it's very simple. So that's the ratio. That's for the angstrom and that's for the nanometer. And it will be what? So it is going to be 1 by 10, right? And 1 by 10 means we are talking about 0.1, simple. So you need to remember these powers. Gigameter is equal to what? So the power of 10 in gigameter, that's 10 to the power 9. For the mega, it's 10 to the power 6. Right, Abhinav? So 10 to the power 9 is for giga. Next, what is the dimensional unit of force? So for force, we had the formula that is mass into acceleration, right? So it's kg meter per second square. So meter, length, that is mass, length, and times power minus 2. So here option number A is the answer. Next, dimension of ratio of pressure to the stress. So guys, if two units are having same units and you will just take the ratio, what answer will you get? So these are those confusing questions. Sumedha, this time you are wrong. See, if units are same, they'll obviously cancel out each other, right? And if they are going to cancel out each other, that will be one only. So here, Pavan, Adi, you are correct. So it will be m to the power 0, L to the power 0, T to the power 0, because it means one only. It's actually dimensionless. So pressure and stress, they have same dimensions. So it will be dimensionless. Electric power unit may be expressed as volt ampere, kilowatt hour, watt second, or joule second. That's volt ampere. That's option number A. P is equal to V into I. Lux is the unit. Lux is the unit of which of the physical quantities? Aviral? Is it luminance, illumination, luminous intensity, or luminous flux? Areva, that's great. So guys, this time you cannot go with luminous intensity because that is actually the unit of candela. So that's not of the lux. Nah, Pavan, that's what I'm saying. Luminous intensity cannot be the answer. It would be illumination because if I'll talk about candela, candela is the unit of luminous intensity, right? Lumen is for luminous flux. So lux, that is the SI of illumination. So here illumination was the correct answer. So these are quite confusing questions, but they are not typical. So you need to be aware of what kind of questions can be framed in the examination. Got it? Okay. Next, which of the following is a scalar quantity? See, scalar quantities are the ones that have only magnitude. They don't have any dimension basically. So guys, if scalar quantity is having any magnitude and there is no such dimension, so if I talk about current, so in the current's case, so we have magnitude also and dimension also, right? But sir, One more thing is there. One second. Its magnitude, it has magnitude and direction both, but it doesn't obey vector addition. And since it doesn't obey vector addition, that's why it is scalar. Understood? So current is scalar because it doesn't obey vector addition. But force is a vector quantity. It's not a scalar. Uh, Krishma and Kirti, force is actually a vector quantity. It's not a scalar. Okay. Which of the following is a vector quantity? So amongst them, so displacement, that is dimension and direction and magnitude both. Which of the following is a vector quantity in these options? So what is it? Force. Next, fundamental quantities are units which are called fundamental physical quantities are called fundamental units, right? Okay. Next, absolute zero. This is the minimum possible temperature at which all the molecular motion ceases. So absolute zero is equal to what? Minus 273.15 degrees centigrade, or in the case of Kelvin, this value will be 0 Kelvin. Okay. Next, choose the fundamental quantity. You have four options. Which of the following is the base quantity, guys? You all can answer. Adi, that's what? Is it force? No. So that's time. Unit was second, and all others units are actually derived. So is the answer. Now we're talking about the rounding off to two significant figures. See, if I talk about 0.0683, let's try to round it off to two significant figures. See, first of all, if zeros are in the starting, we will ignore that. So this is the first significant figure. Second significant figure, just make a line here. Just check. The next digit is 5 or greater than 5. So it's neither 5 nor greater than 5. Just write as it is. So it's 0.068 as the answer. If it is greater than 5 or it is 5 also, just add one in it. So Adi, please try to understand the question. It's like you have to round it off to two significant figures. So you'll ignore this. So this is the first significant figure, second one, and you have to just check, is it 5 or greater than 5? No, it's lesser than 5, so it will be as it is. So it's 0.068. Next, tell me about this. If you understand this, or if you have understood this, you can easily answer. So see guys, I know the time's already up, but I need this uh, because in the examination these questions are asked. So please try to understand, and wherever you feel like you have any doubt, please ask. So Nanny is going with D, fine. Uh, Krishma is going with D. All of you are going with D, great. So now that's correct. It was 0.0687. It was talking about two significant figures, so we'll ignore this. First, second, just draw a line. It is greater than 5, so it will be plus 1. So 0.069. That's great, guys. Perfect. Next, Kirti, Abhinav, you have to round it off to three significant figure now. 3, 0.13645. Please start answering. So guys, 3. So we'll ignore 0. So it's 1, 2, 3 up to 6. After 6, we have 4. What is it? Just let me change the color. We'll ignore it. So it's 1, it's 2, it's 3. Just draw the line. Just check. Is it 5 or less than 5? Is it 5 or greater than 5? No. Smaller. Just leave as it is. So 0.136, that is option number D. So Nani, Sumedha, Krishma, great. Next, Aviral, this 0.13645 rounded off to four significant figures. Answer. Just ignore this stuff. 1, 2, 3, 4 line. So is it 5 or greater than 5? So it's greater than 5. So you need to go with plus 1. 1365. So that's again B. Yeah. So Sumedha, Kirti, Nani, Vaishravi, Aditya, Gauze, Aviral, you all are correct. Here the correct answer is B. What about this? 77.61. And guys, this time there's no leading zero, right? So yes, we'll count it from here only. 1, 2, and 3. Line. Less than 5. Don't do anything. as it is 77.6. Option number A is the answer. Great man, perfect. Next, 77.61, let me write it for you. 77.61 to two significant figures. That's the first one. This is second one. Just draw a line, just check. Is it 5 or greater than 5? Yes, it's greater than 5, so plus 1. 77 plus 1, 78. Arey wow. Pavan, Aviral, uh, Veshu, Nani, great. You all are correct, Kirti. So option number B is the correct answer. And this is the last question of the day. 1845 to two significant figures. Guys, it's 1845. It's not decimal here, please. So up to two significant figures, we'll start with the first one. So 1, 2, just draw a line and just check. So less than 5. Okay. So it will be what? 1800. Perfect, guys. Perfect. Because if it would have been 18.45 or something like that, then you can say that it's 18. But it's not 18.45, right? It's if it would have been 18.45, you would have given answer 18. But it's 1845. That's why answer will be 1800. I thought that most of you would be wrong here, but each and every candidate was correct. So we have understood every concept, and I have already given the explanation, but this is only for the knowledge purpose. But I have already explained all the things. So that's all from mine, guys. We'll meet in the next class with the force and motion, but that force and motion is a bigger topic, and I have some animation and some more explanations there. So I'll take that lecture in two parts. So in the next class, we'll meet with the force and motion part 1 and then part 2. So on the we'll take 2 days to complete that topic. Yeah, but as of now, if you have any doubts, any questions or queries, just let me know, because it's already 2. I guess next class is waiting for you. So my class is also waiting, so I need to go, guys. So thank you for being such a wonderful audience. Thank you, Kotesh. Thank you, Nani. Thank you, Kirti. Thank you, Jose. Thank you, Abhinav. Thank you, everyone, for being such a wonderful audience. Please meet sharp on next day, and the next class will be force and laws of motion. Please take care. Bye bye.